In verifying identities, we first need to remember the reciprocal identities, which are
Sine theta is equal to 1 over secant theta. Cosine theta is equal to 1 over secant theta. Tangent theta is equal to 1 over cotangent theta. Cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. Cotangent theta is equal to 1 over tangent theta.
For the ratio identities, we have
Tangent theta is equal to sine theta over cosine theta. Cotangent theta is equal to cosine theta over sine theta. And lastly, for the Pythagorean identities, x squared over r squared plus y squared over r squared is equal to r squared over r squared. Cosine squared theta plus sine squared theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta. Cotangent squared theta plus 1 is equal to cosecant squared theta. For number 1, sine to the 4th x minus cosine to the 4th x over sine squared x minus cosine squared x is equal to 1.
Using the difference of two squares, expand the given to sine squared x plus cosine squared x multiplied by sine squared x minus cosine squared x over sine squared x minus cosine squared x. Cancel sine squared x minus cosine squared x for us to have sine squared x plus cosine squared x, which is equal to 1 because of the Pythagorean identity.
For number 2, sine to the 4th x minus cosine to the 4th x is equal to 1 minus 2 cosine squared x.
By using the difference of two squares, expand the given to sine squared x minus cosine squared x multiplied by sine squared x plus cosine squared x equals 1 minus 2 cosine squared x. Change sine squared x plus cosine squared x to 1, knowing sine squared x is equal to 1 minus cosine squared x. We end up with 1 multiplied by 1 minus cosine squared x minus cosine squared x equals 1 minus 2 cosine squared x. Add the two negative cosine squared x together to have 1 minus 2 cosine squared x equals 1 minus 2 cosine squared x.
For the third one, cosecant x over sine x minus cotangent x over tangent x is equal to 1.
Start by converting cosecant x over sine x onto 1 over sine x divided by sine x. Multiply 1 over sine x onto itself. We get 1 over sine squared x. Going back to cotangent over tangent x, convert it into cosine x over sine x divided by sine x over cosine x. Multiply cosine x over sine x to the reciprocal of the sine x over cosine x, which is cosine x over sine x, and we would get cosine squared x over sine squared x minus 1 over sine squared x minus cosine squared x over sine squared x, which is equal to 1 minus cosine squared x over sine squared x. Knowing 1 minus cosine squared x is equal to sine squared x over sine squared x will be equivalent to 1.
For number 4, 1 minus sine x over cosine x is equal to cosine x over 1 plus sine x.
Multiply 1 minus sine x over cosine x by 1 plus sine x over 1 plus sine x, which will be equal to 1 minus sine x multiplied by 1 plus sine x over cosine x times 1 plus sine x. Multiply 1 minus sine x to 1 plus sine x to have 1 minus sine squared x over cosine x times 1 plus sine x, knowing 1 minus sine squared x is equal to cosine squared x over cosine x times 1 plus sine, cancel cosine x, which will leave cosine x over 1 plus sine x.
For the last one, cosine squared theta is equal to cosecant theta times cosine theta over tangent theta plus cotangent theta.
Convert cosecant theta times cosine theta over tangent theta plus cotangent theta into 1 over sine theta multiplied by cosine theta divided by sine theta over cosine theta plus cosine theta over sine theta. We get 1 over sine theta multiplied by cosine theta over 1 divided by sine squared theta over cosine theta sine theta plus cosine squared theta over cosine theta sine theta by butterfly method. Simplify it to have cosine theta over sine theta divided by sine squared theta plus cosine squared theta over cosine theta sine theta. Turn sine squared theta plus cosine squared theta into 1 using the Pythagorean identity, then have a value cosine theta over sine theta divided by 1 over cosine theta sine theta. Multiply cosine theta over sine theta to 1 over cosine theta sine theta using the reciprocal identity to have a product of cosine squared theta over 1 or cosine squared theta.